If we have a surface grid, such as a digital elevation model shown on the bottom here, we can make a nice 3D display by taking an aerial photograph, like the one on the top, and draping it on top of the DEM. This shows an example here of some bathymetric data. The top layer is the grid, and as we can see, the colors get darker blue to purple as we go deeper and deeper. And the one on the bottom shows that digital elevation model in 3D, as if it were draped on top of the digital elevation model, the various colors that we see in the top here. So these type of surface grids are nice for making three-dimensional displays. The problem is we don't always have a grid to start with. Let's look at an example here where this is Butte, Montana, and Butte was an old mining district in Montana. This is the hill here, Butte Hill, where a lot of the mining went on. At first it was underground mining, and then after a while a big open pit copper mine came in this area here. We had a historical map of this area, and this historical map includes lots of elevation data. We can see all of the elevation contours on here, and it goes across this entire map from the early 1900s. What we did was we digitized those contours, and then once we had those contours digitized, we had all of the elevation data associated with the terrain in this area, and we converted that into a DEM. So this has now gone from contours to a regular grid to show what the elevation looked like before all of these changes went on here. The biggest changes here are that this area here is going to be converted into an open pit copper mine, and all the material they took from here was put over here into a tailings pond and tailings dam in this little valley on this side over here. So this is what the terrain looked like historically around the beginning of 1900. Once again, here is the area with the most intensive mining, and here is the area where once they started the open pit copper mining, all of the tailings, all of the waste rock from the mine would be put. This is what it currently looks like today. There's a giant hole in the ground. This is an open pit copper mine. It's called the Berkeley Pit in Butte, Montana. And the purple here is showing the water level. This water is extremely acidic, and obviously could be a natural or a hazard to the environment. And we can see all the other sorts of mining operations over here. Here's that tailings stuff, the tailings here, and the tailings dam is right at the top here. There's actually water up here as well. What we can do though is we can take the old surface from the historical map and the new surface from mapping that they've done in the pit, and we can make a 3D model. And what we're basically doing is just putting one surface on top of another surface, and the area between those two surfaces is all of the volume of material that has been removed historically from the Berkeley Pit. Another thing that we can look at as two different surfaces is this. It's called the Yankee Doodle's tailing dam, or tailing pond, and the Yankee Doodle Dam, which is over in this area here. So all of the material once again was removed from here, put over here. We can look at how that looked historically. Here's the area of the future Berkeley Pit, and here's the valley next to it. And after they dumped all that material they removed from the pit there, they basically filled in that entire area there and really changed the terrain. And once again, we're just doing this by basically mapping one surface on top of another surface. We're starting with the historical map of Butte, and then we're adding the top of the current day tailings pond and tailings dam to that, and showing it all as two different 3D surface grids. Of course, it's not just terrain that can be mapped as a grid. Anything that's represented by smooth changes in values can be shown as a grid. In this example here, we're looking at aeromagnetic data for the state of Montana. So this is data that they collected by flying over the state and just measuring how strong the magnetic field was in these various areas. So depending on the underlying rock, you can have different responses. We could represent that as contours on top of this geologic map. The geologic map is shown in color underneath. But sometimes it's hard to tell, for example, how high these highs are over here with respect to these highs here, just because contours aren't the easiest way to see the data. But if we take those values and we represent the aeromagnetic data as a grid, now we can show that grid in 3 dimensions. And now we can clearly see some relationships, such as relationships between the igneous intrusives shown in red and some of these some of these very high points here, and how the aeromagnetic data varies across the entire state. So this is a surface grid, but it's no longer representing terrain. It's representing instead aeromagnetic measurements across the state of Montana.